In this video, I'm going to show you how to take a system of equations like this one and classify it. Now, the method I'm going to use now is going to depend on using a graphing calculator, so make sure you have one of these handy. Before we even do it, let me point out a couple of things. The most common case is you will solve a system like this and you will get one solution like x equals -2, y equals 3, and z equals 7. When you get one solution like this, that is called consistent and independent. So when we solve this in a minute, if it comes out to be a single solution, then we're going to pick this. So you should probably write down some notes right now. So this will be how you classify it whenever there's one solution. All right, inconsistent means no solution. So if it's going to be inconsistent, okay, that's only going to happen when there's no solution. Now, when it's inconsistent, it's normally inconsistent and independent. All right, these two usually go together. So I just don't think this answer is ever going to be the answer. So just don't pick that one. This is the one we're going to pick when it's infinitely many solutions. Okay, so when it's one solution, it'll be really obvious. So real quick, I need to teach you how to recognize when it's no solution and when it's infinitely many. So come with me off to the side screen for a second. So we're going to write these systems in what's called reduced row echelon form. So when it's one solution, it's going to look like this: 1 0 0 0 1 0 0 0 1. Okay, this is what it will look like on the left when it's one solution. Okay, and over here, this is where your answers will be. So you will have things like -7, 3, 1. You know, these could be whatever they want to be. They could even be 0. You could have a 0 in here. Okay, 0 is allowed as an answer. All right, because this would mean x equals -7, y equals 0, and z equals 1. All right, the 1, 1, 1 represent x, y, and z. So now let me show you what it looks like when it is no solution. All right, when it's no solution, the real problems happen in the bottom row. So stay tuned for that. Okay. So we might have something like this. In the bottom row, I have 0, 0, 0. Okay, so let's say over here, I have -7. This still doesn't matter. I'll just say 2. But right here, I have to have a number. If it's going to be no solution, there won't be another 0 here. It'll be a number here. Okay? Because this tells me that, and really I'm just looking at the bottom row is where the problem happens. Because these are all zeros, that means there are no variables here. That means this is literally 0. So this is telling me that 0 equals 5. But that doesn't make any sense. 0 does not equal 5. That's why this is no solution. Okay, so it's all about that bottom row. Okay, all right, I need to create a little space here. All right, so here's the last little example. Here's what it looks like when it is infinitely many. Okay, and I'm really just focusing on the bottom row again. It's still going to be 0, 0, 0 down here. So the first two numbers don't matter. I'm just going to stick to -7 and 2 for a second. But if the last answer again is 0, so this means because on the left I have all zeros, so that's a 0, and on the right I have 0, then that's telling me that 0 equals 0. Well, guess what? 0 does equal 0. 0 always equals 0. That's why you're going to have infinitely many solutions, because no matter what you get, you're going to have 0 equals 0. Okay, so use this, write these notes down and use that as a guide so you know if it's one solution. And if it's one solution, we're going to pick option C. If it's no solution, we're going to pick D. And if it's infinitely many solutions, we're going to pick B. So now I need to show you how to write this matrix in reduced row echelon form. So first of all, let me create some space. The coefficient matrix here is 5, 1, 2, and then we have the 13. Okay, so I'm kind of drawing a line here. And then we have 4, 3, 6, and then 17. Got to be careful here. We're missing the z. So this x gives me a 1 right here, not over in the second column, in the first column. 2y, so that 2 goes here. The 0 goes here to represent the fact that we have no z's. And then we have the 4 here. So this is the what they call the augmented matrix. So we're going to type that into our calculator right now. Okay, I guess I'll just jump back and forth real fast. Okay, so go to the matrix area by hitting second matrix and then switch over to the edit menu and hit enter. This matrix is a 3 by 4 matrix, 3 rows, 4 columns. So I'm going to type in 3, enter, 4, enter to change the dimensions. 5, 1, 2, 13. So 5, 1, 2, 13. 4, 3, 6, 17. 4, 3, 6, 17. 1, 2, 0, 4. All right, once you type the matrix in, you got to quit your way out. So hit second mode in order to quit. So we want reduced row echelon form. So hit second matrix again. This time slide over to the math menu. It's going to be near the bottom. See right here where it says RREF. That stands for reduced row echelon form. Choose that. So we want to do this to the matrix we just made, which is matrix A. So go back to the matrix area one more time. This time leave it on names and just hit enter. So this will put matrix A in reduced row echelon form. Boom. Okay, so notice how we have 1, 0, 0, 0, 1, 0, 0, 0, 1. This is what we get when there is one solution. That's the very first thing I showed you. Okay, so that means the answer should be C. Ta-da!